All right, thank you for everyone to attending today's webinar. Today we are going to discuss integration simulation with the CAD for part design. My name is Casey, application engineer from MoX3D. So let's talk about design for manufacturing, and we will focus on what is current challenges and what is modern 3D application in automotive industry, and what is the need for design for manufacturing with upfront simulation, and what can Modex 3D do for design for manufacturing. We also are going to have some cases and also support visions for CAD systems, and we have demo cases going to share as well. So let's talk about the thermoplastic. What are the challenges for thermoplastic parts? So for example, the thickness of the part, too thin, too thick. Too thin will cause that hesitation. Too thick material will be easier to flow, so which will cause an unbalanced flow. The wall line issue, think mark shrinkage, and the pressure you need to understand what is the machine we need. Otherwise, will cause short shot issue. And a lot of times when part designers are designing the parts, maybe the part is not able to mold it, or the part designer does not understand the material property well enough. That's why it causes the manufacturing engineers or tooling engineers hard to build a good tool or mold in order to have good parts. In order to achieve a good part, there are a lot of things we are able to do in the upfront. So based on our experience, a lot of time when the designer design the part, however, the tooling or manufacturing engineer has go back to the part designer and ask, change the part thickness or aiding the rib or modify geometry or aiding the flow leaders. Those are aiding the time into the entire cycle. So basically, we are wasting a lot of time, and time is the cost. And here are some examples to show you. So for example, on the top left, this shows you how much pressure we need in order to fill the part. And in the middle is showing the hesitation. On the top of right, showing where are those four aligned locations. And those are the challenges of the part quality. And this is an example with a mu cell technology, which is published back to 2011. So for they use the mu cell technology in order to understand how much is clamping force we need, how much is pressure we need in order for this forming process. If this forming process help us to reduce warpage or not. So this is application we use back to 2011. And this is another validation of warpage. This is a glove box on the passenger side. On the right, it's a simulation versus experimental data comparison. If you are seeing the green colors, means overall the prediction is good. But if you are seeing the red or purple colors, either it is under predict or over predict. And this is also shows you the benefit to use a simulation, how much money we are able to save per tool. And this is one of the users they share back to many years ago. So you can see the history of 2004 up to 2010. So let's talk about in the current design workflow. Once the part design is freezed, then the part will be releasing to the tooling engineers. And the tooling engineers will need to go back to the part design and ask design engineers to change the design change, which the iterations cost a lot of time consuming. As we know, if we are able to change the part design, the opportunity to reduce the cost will be much less. If we have to go to a tooling or manufacturing to do the design change, the cost will be much higher than part design. So this is the chart explained. In the early design phase, we have more freedom to do the design change, and this is gonna help us to save more cost. So right now, what can Modex 3D do is we are able to help the part designers to do the upfront simulation in the early design phase. So basically, it helps for the tooling or manufacturing engineers to eliminate those iterations to make sure the part is designed good enough so the tooling guy or manufacturer side, they are able to build a better tool or modes. And in order, the current challenge for design for manufacturing is the challenge getting more complicated and material property and those features. And those features will help us to input into a simulation and help the designers identify those challenges. So let's take a look on what Modex are able to do in the early design phase for design for manufacturing. So right now, Modex, we have a module, a product called Sync. And this Sync product is integrated into the CAD environment, which means for CAD designers, they are able to run quick flow simulation. And this Sync module feature is integrated with the Creo PTC, NX, and the SolidWorks. So for CAD designer, they are able to do those design change when they are starting to design the parts. And based on the Sync, we are able to generate automatic mesh and also generate report automatically. And we also support parallel computing. So the CAD designers are able to run a flow, pack, cool, warp, fiber orientation, and insert molding or over molding in the early design phase. Based on the Sync, it's easy for CAD designers. They are able to, based on the thermoplastic process, to use a default flow packing pressure to see if where is the wall location, how much pressure you need in order to fill the part without getting short shots, and also understand material shrinkage, etc. So basically, here's workflow of Sync with the Creo, NX, and the SolidWorks. And Modex 3D Sync will take care of the 3D mesh generating and do the calculation for flow, pack, cool, and also present results inside CAD systems. Once the CAD designer review the result and the result is not good, then designers could go back to the modeling, go back to CAD system to change the part geometry again. So inside the Creo, we also have Creo mode analysis. Inside NX, we have NX Easy Fill and Advanced. So those are the license or modules the CAD designers are able to use in order to identify air trap, flow, how the material flow, how much pressure, where's the material shrinkage, etc. So those part designers are able to use a CMA, EFA, if they want to extend to understand material shrinkage, how is the rounder, how is the shrinkage or insert molding, over molding, or fiber orientation. Those will be able to see inside Sync system. So this is just give us a quick example. So on the top left, this is original mold design. Once you run the quick flow, you could see there's one side material flow faster than the other side. And once you are seeing the air trap or welding location not good, then we could go back to change the part thickness, make the material flow much more balanced, And this is just give us one of example how the sync are able to help CAD designers. We also provide the gate location. A lot of designers, they don't have a lot of experience, and we have gate location advisor based on the numbers of your gate and give you where is the best gate location. Also, we could give an estimate cooling time and understand which area we would need to cool down the parts. So CAD designers are able to go back to adjust by the thickness to make sure the cycle time is good enough. Another one will be sync mark or L over T indicators. And those are the quick estimations for CAD designers to understand is the L over T too long or too short. In the flow result, we could show you air trap, water line, and also show the clamping features so you could understand the pressure temperature through the cross section. And here's the complete capabilities from flow, how the material flow, taking how much pressure you need, cooling, understand where's the hot spot, and shows the workpiece results. And also including fiber orientation and the insert deflection if you are doing the insert molding. Here it shows you how the sync integrate with the PTC Creo, NX, or SolidWorks. So the CAD designers, they could base on the environment which they are familiar with and do those quick flow simulation inside the CAD system. We also support automatic reports. So based after once the simulation is finished, the report will be generated automatically. If you want a more advanced simulation, we also support API. So system will automatically to run those simulations inside through the API application. Here is versions we could support for PTC, NX, and SolidWorks. So for Creo, up to 5.0, for NX, up to 12, for SolidWorks, up to 2019. So let's take on the demo case. This is inside SolidWorks. We are going to import the components which we are going to simulate. As you can see, this is one of the thermoplastic design. And the users are able to draw those runner system or cooling system. So now this is assembly part for the cooling and the runner system. So once you click sync, then the interface will pop out. So we are going to set up the attribute for each component. So runner will be runner and part will be thermoplastic. So on the left windows, you can see this is going to be our part. And we could choose the materials in our material data bank. In current our material data bank, we have almost 9,000 materials. And once we define material property, the next will be the runner. If you don't know the runner geometry, you could just add in the gates on the part and do the quick flow simulation and understand how the material is going to flow. And we are going to put a male entrance on the top of the runner. Now we are going to create a mold base. And in the MOBES, you are able to define your MOBES properties. It could be P20 or H13. Now we are going to define those cooling channels. Now we are going to define how the water is going to flow in and flow out. So that's our cooling inlet and the cooling outlet. So once the cooling inlet and outlet is finished, the next step will be generating the mesh, and Modex will take care of the mesh generating. And once it's mesh generated, then we are going to run flow simulation. Also in the top middle, you could see those are get advisor, cooling time indicator, L over T indicators, and sync mark indicators in the middle of top. So I am going to forward, and you can see simulation is going to about to run. Okay, so the next one I am going to share is a case study, which is a connector part, the same workflow. You define the runner, the attribute, and then select material process, no entrance, and MOBES. And now we are going to run simulation now. So now we are going to review the results of the original design. And this is a mail from results. And based on the mail from results, you could see there's a hesitations. So that's why material flow faster in one side, slower in the other side. And you also could see the air trap occurs in that location. And this is another air trap location. So now we are going to do is we are going back to the CAD system to change the part thickness to make the material flow balance. Some people might want to add in flow leaders if necessary. Now, so we are going to run the simulation again to see the new revised design will give us better results or not. So we will run the simulation. So you can see the previous air trap location is due to flow balance is better than before. And also the second air trap location. And of course, the warpage is also being reduced too. So the concept of the sink or what can Modex 3D do is help in the early design phase to review the result. If the result is not good, then we go back to modify the CAD geometry, then review the results again. All right, so this is my today's presentation.